Go. We're live. February 16th. All right, a new day, a new challenge. Before we start, let's take a look at the notifications. Oh, I have so many. Huh. No idea what they are. Move on to today's challenge. Oh, permutation. I hate permutation. I do not like permutation at all. Letter case permutation. Given a string, we can transform every letter individually to be lowercase or uppercase to create another string. Return a list of all possible strings we could create. We can return the output in any order. Okay, so we are not changing the order within the string, but just do the letter case. Okay, letter case. All right. S will be a string with length between 1 and 12. Ooh, only 1 and 12. Maybe you can brute force this. Oh, wait, hold on a second. 12. If 12, if we want to permute 12, is it 12 factorial? Oh, no, you cannot. 12 factorial is 479 million. So, nope. You cannot. You have to do it smarter. S will consist only of letters or digits. No, wait, is that factorial though? Alright, we're not changing positions. No, it's actually not. It's not permutation. It's not permutation. In fact, I give you A and B, right? If it's, it is permutation. A and B, we can get big A, small b. It's actually 4. Oh my god. Small a, small b, big A, small b, small a, big B, and big A, big B. That's just 2. Alright. Permutation. Usually the way to do permutation is via recursion. So let's just take A1, B2 as an example, right? So A1, B2, hold on, it doesn't say that inputs are all lowercase. Actually, it doesn't matter. It doesn't matter if it's a lowercase or uppercase. You know what? Let's try. I don't think it matters. Let's just say if the input has an uppercase. I think it'll be the same result. Yeah, it's the same result. So what we're saying is if I given A1, B2, so the solution is we take A out and we're gonna permute 1, B2. And then for 1, B2, we're gonna take 1 out and gonna permute B2. So B2 we're gonna permute, we take B out, we permute 2. And 2 permute, there's no permute for 2, so 2 returns. Now B2 permutes with B, can change it to uppercase B and small case b. So B2 will return as a list of big B2 and small b2. And then 1 does not permute, we add 1 to the front, return to the top. Now we have A, so we have big A1, big B2, big A1, small b2, small A1, big B2, small A1, small b2, and then we're done. Alright, I think this is the solution. Okay, doesn't seem too bad. Take a look at the at how we're gonna do it. Alright. It's a recursion. We don't have too big a test. We don't have a too big string to work with, so it should be fine. So recursion, how do we recurse? Can we do it directly? I think we actually can recurse based on the letter case permutation. Basically means if we say if 0 smaller equal to s smaller equal to 9, that means it's we're going to return. What do we return? We has to return a s like that. If a smaller equal to is it 2 lower? Oh my god. S dot 2 lower? I forgot. What is the function for this? Is it called 2 lower, 2 upper? Dot 2. No, it doesn't have it. 2 lower. No, I think it's just lower. No. A dot lower. Oh yeah. That's the one. A dot lower. So a s dot lower smaller equal to a to z. Then we return two things: s dot lower and s dot upper. Okay. Else, oh no, which actually has to be is a single. So if len s is 1, and then we do this, and then we say else. I have 2, then we are going to say rest equals self.letter. This, I'm going to pass in s 1 to the n, and then we're going to do return for r in rest. Oh, I can actually I'll do it later. For r in rest, what we're going to do is, how do we do this? We have the chain, right? We have the chain. Man, I forgot how to use chain. Because it has to be two things, right? We're doing two things. We want to flatten. We want to flatten a list of lists. How do we flatten a list of lists? All right, I think it's iter tool. Chain is in the iter tool, I think. Chain. All right, chain A, B, C, D, E, F into this. Okay, so return what? Treating consecutive sequence as a single sequence. Making an iterator that returns element from the first iterable until it is exhausted. Okay, so I think we can return. So we can do s0, right, dot lower plus r, and s0 dot upper plus r. And then we're going to have to chain this. Chain it. And this actually doesn't have to be a list. It could be an iterator. We're going to chain it, but eventually we have to turn it into a list. I think I can just turn it into a list by doing this. I don't have to actually type list. Okay. And this can be put in here. And it's complaining. What are you complaining about? Chain. Okay, this one does not exist. Okay. So let's see. If equals 1. Actually, I don't need else because both of this is returned. So it's going to be like this. All right, let's test. We'll have to pass the chain. So from iter tools port chain. So go back to here. We have our test case. First test case is 1A1B2, which should give us Oh man, it is not going to be the same. That's fine. We can do something about it. It's not too big an issue. We can just turn everything into a set if we want to test this. So 3z4 is going to be 3z4 and 3z4. Oh, and one more thing. If it's let's say, oh man, this is going to be a long sentence. If S0 dot is alpha. Oh. Else, we're just going to pass S0 plus R. And this can be if S dot is numeric, if S dot is alpha, right? And then if it's alpha, do this. If it's numeric, we do this. And then we just one line turn. Okay, what's the next? Next is 1, 2, 3, 4, 5. Which we get 1, 2, 3, 4, 5. And finally, I think we have 0, which should give us 0. Okay, so bigger S, and this is going to be a letter bigger S, and it's going to be set res equals set answer. Try it. Fail. Oh, what the heck? Okay, this is not working, so probably list. We'll have to do list. Nope. Unsupported. What is unsupported? Plus built-in function NSTR. Alright, I think we it's a little bit maybe too complicated. When a chain okay, so this, if this, else we do this for R in this. So this one returns a list. So this one we get a list, and each value is a individual. And the individual we can add to the individual, and then we chain it, and then we list it. Well, what was the problem? Huh. Alright, let's do the stupid way just to see if it works. Alright, so the stupid way is just announce a new thing. Okay, let's do a stupid way first. So we say rest equals self.letter s1, and then result. Oh man, it looks too similar. Result is this, and then we say for R in rest, if S0 dot is alpha, then rest dot append, when append S0 dot lower plus R and dot upper plus R. Else, which means it's not alpha, then we do rest dot append S0 plus R. and then we're gonna return this. And this actually can still put it down there, so I don't have to add this. Okay, that shall work. Yeah, let's try it. Yeah, this one works. But why is this one does not work? So this is all the same. And if it's alpha, we do this. Is it because of the chain? All right, let's see. Let's see if the chain works. So from iter tools, import chain. So if we do chain, right, and then we say 1, 2, 3, 4, 5, right, and then we list it. Huh. It is not working. Why? Hey, hold on. How does chain work? Chain. Okay, I think chain has to be like this. Yeah, so it cannot be a list of lists. It has to be a list by itself. Okay, so which means we chain. It is an iterable and another iterable. So okay, so we know that this does not work, right? But we can make it work by doing this. And turn this into a, so this is this. This one is for chain, so we do this. And we use a star. It's still not working. Okay, let's go back here. What I'm trying to do is, I say, if I put a star here, it works. If I put a star here, it works. But why is this one not working? Right, if it's alpha, else we do this, for R in this, for R in this, and we put it in a this, and I chain it, and I list it. Built-in functional method and str. I'm adding a built-in functional method? I am not adding a built-in functional method. Oh, you're returning a list. Is that what it is? It shouldn't be. Okay. Yeah, I'm a bit confused right now. So we need a, for this, and not this. Nope, nope, nope. I don't understand. Why is this not working? List comprehension with chain. Alright, I think we need a little bit help here. So let's say list chain, right? And we say a plus 1 for a in range 3. Okay, so this one does not give us the one we want. Then how about I put a this here? Cannot be comprehends, which is right because this is actually wrong. So we put this here. Yeah, it works. It works. 0, 1, 1, 2, 2, 3. It works. Okay, let's do this. If A is odd, else if A is even, we just do A. Even, odd, even. Yeah, it works. Why is this not working? If it's alpha, else we return this for R in self dot this, and then we put everything in this, and we unload it, and then we chain it, and we eventually return it. So anyway, so we're gonna just keep going. Eventually, we're gonna go here, right? And once we come here, it gets out. It's 201, right? And then a single thing. I think I can still do. Like even if it's a single thing, I can still do it. Okay, this is not algorithm related. This is just basically it's not working. But the test shows it works. What is the issue here? Like what exactly is wrong? I mean, oh my goodness, I see it. I see it. Talking about stupidity. Can only concatenate str to str. Alright, what is the issue here? So you're saying, yeah, I think we said it has to be list. It has to be list. There we go. Oh my goodness. Was a silly mistake. I forgot to put parentheses around. Alright, we need chain. Alright, let's test it. And we don't have to test it, let's just submit it. And we done it. And we done it. And we are at 74%. So I like to write this something called straightforward solution. We got a little bit stuck halfway because I forgot to put parentheses around. But overall, it's pretty good. Use recursion. You hold one letter, hold the first letter, and recursively call the same function on the remaining string. Once the remaining string is done, we append left. We append left the case permutation of the first letter. I don't know. What's the complexity of this? I mean, there's on for every one, and then each one could be. That's actually on because this is. No, that's actually not on. It's I don't know. Honestly, I don't know because depending on how many permutations you have. So say the worst case scenario, so everything is all letters, and the last one will be having 2, and this one is 2 times 2 because it has 2, and next one is also 2, so 2 times 2, so 2 to the n. I think the complexity is 2 to the n. Worst case. That is, all letters are. The string is only letters. The string has no numbers. And we run this at 56 milliseconds, which ranks us at 74%. All right, that's about my solution. Let's go take a look. Difficulty, most likely this is an easy question. Yeah, I think this is an easy question. It's a very basic recursion, very basic recursion. I'll be surprised if it's medium, but I think it's easy. Medium. This was easy. That's medium low, not medium low. Not really. 784. Not really. Oh, BFS, DFS. 7 lines. Hey, 1, 2, 3, 4, 5. I got 6 lines. That's a. Okay, so a few things we want to check, right? This I want to check. Backtracking with trick. This one is the most voted, so we're probably gonna check. Backtracking, if I take a look. DFS backtrack. Mr. Lee, definitely. And honest backtrack. He just did it, so we're gonna check that one as well. Okay, let's see. Okay, it's alpha. Oh, is it straightforward iterative? Okay. Wait, hold on. So we start with empty string. So we check each character. If the character is alpha, okay, if the character is not alpha, then I in result. So we check every one. Oh, I think this is also recursion, but recursion kind of in a different way. So for each letter, and we already created the results, and then we just added. Okay, yep. Yep, it's the same. I don't think it's O-N. Yeah, it's a 2 to the n. It's the same as this, but iterative. Pretty smart. If you want to do like really, yeah, let's make it really short. Really short. How do we do really short? I think I can shrink it down to 3 lines. So if s is 1, then we return. I like as alpha. I'll return this if alpha, else s. Yep. and then you can actually do it in one line, right? This is right, and then all right. Let's hold on. We actually have okay. I know what to do. I know what to do. Let's write a right in the most explicit version. So R in this res if s 0 dot is alpha, then res actually do this s this and then this, else res dot append s0 plus r. And we have to save this. We want to return res. Okay, so this is the most explicit algorithm. Now we're gonna do it. We have to say post this, and then I'm gonna say one-liner. It is a smart ass one-liner. Return. Okay, so we return this. Return this if s dot if len s is 1, else return this. So if 1, we return this and this. If s dot is alpha, else s. Yeah, let's just see if solution 2. Return outside function. I have another return here. Return this if is alpha, else this. So maybe I just need to add some parentheses. Return this if else this. Nope. Return outside function. Oh, cannot do it? Return this if else. So return this if s equals 1, else this. Nope. Why cannot chain it this way? Huh. Return says return outside function. I don't understand. Return outside function. What is this? Hold on. Check. Return outside function. Syntax error. Oh! There we go. Oh my god. This is... Alright, this is a smart-ass one-liner. Let's see if anybody posted a one-liner before. Yeah, this is good. This is good, but I like your recursion though. Discuss. Yeah, let's post it. Yeah, let's post it, just for fun. And I say Python unreadable, convoluted one-liner. Highly unreadable. One line. And this is a highly unreadable but highly unreadable one-liner just for the lols. I might not even have to include this parentheses. I think it probably, yeah, it works as well. I don't have to include the parentheses. Oh my god. I think it's this one and this one. Highly unreadable one-liner just for the lols. Yeah, basically it's for the lols. Let me submit it. Let's just see. It should receive a similar performance. I don't have any reason to believe this one will give us anything different. I think it's the same. But, you know, it's fun. It's very fun. Oh! Hold on! Hold on! This is not correct. Wait, how? How is this not correct? Wait a second, wait a second. Wait a second, it's not correct. No way, this is the same, I translate the same algorithm. How is this not correct? Oh my goodness. Wait, hold on. Do I have to add the... Yeah, I think you have to add the parentheses, man. Yeah, okay, the parentheses is required. Otherwise, yeah, the parentheses is required. If else, yeah, this. Yeah, the parentheses is required. Yep, it's the same. We have to change our post. Newest. Let me change it. No, the parentheses is required for this. If else, yeah, I think it's here. Yep, update. Okay. Highly irritable, one line. Reduce. Map. Reduce. Using reduce. I have no idea what this is. Oh. Mine is highly unreadable. But actually, nah, I don't know. Do you think this is readable? Yeah, I don't really like reduce and stuff. But they're solving it. Anyway, we know what that solution is. It's like, oh yeah, that's another way. Yeah. Think about it. That's another way to handle permutation. You just have a result, and every time you just update the result. You have a result, and you put one letter in to all the result, and then you check the second letter, and you go again the results again and add your result. Actually, we can do this. I think we can do this. I want to try. This solution. I think it's more standard. Res equals this, and I would just say for I like to say letter in S, right? And then what we're gonna do is res if letter is alpha, right? If letter is alpha, then I want to say res equals how do you use one line to have to use a chain? Yeah, I have to use a chain. There's no other way. If it's alpha, then it has to be r plus dot lower, r plus dot upper, r in res, and then this thing has to be chained. How do you do this without chain? And then list it. Wait, does he do it without chain? Did you do it without chain? Oh no, that's not a solution. That's this one. Oh, 4. So 4 and 4. Ah. Okay. Else res equals r plus letter for r in res, and then return res. Okay, this is a solution 3. What is wrong with you? Okay, only can add a list, not str to the list. Oh, my bad. It says the chain. Yep. I mean, so basically we can do the same thing. We can say res equals this if and else do this. Right? Chain it and list it. Okay, yeah, so that's iterative solution. Inspired by, let's give credits where credits due. Inspired by this. Okay, that's good. Alright, what about this? First, let me draw a figure. Is that a typical BFS, DFS problem? ABC, A, and then AB. I don't, wait, how? Oh, is that kind of problem? How is this? I don't understand. How is this? It push what in? well, like these are the layers, and you handle first, and you push in two. One is small, one is big. Okay, you pop this out, and then what? You do the second. One is small, one is big. Pop this one out, second one big, and then third one, third thing. Okay, yep. It is a BFS. It is a BFS. I agree. It is a BFS. I probably don't want to go for the DFS. BFS is good enough. DFS, what's DFS? So we go all the way down. So first level, second level, right? First, second, third, coming back, down, a third one change, right? Coming back, this one change, and down. Now, BFS is easier to understand. If character is digit, then we continue. That is true. I'm talking about level, right? It's a level, and we pop everything from the queue, and if it's a level, we're gonna continue, and we don't worry about. Then we just go to the next size. Okay. Okay, yeah, I understand why it is it can be a DFS or BFS. Yeah, it is a binary tree. Oh, that is BFS. It is true. It is true, but it probably not gonna be really using BFS. I think, I mean, the natural solution, this is my natural solution, right? And then you can smart ass into one-liner. This is actually, if you think about it, this can be combined into whatever map reduce thing. All right. This is what? Backtracking. Why do you need backtracking, though? Result, dot push. So we go all the way down. What the hell? Why are you guys doing this? Oh my goodness. Toggle case. Okay. So for everyone, we toggle its case. And then, where did the backtrack happen then? Oh, we backtrack first. We keep calling backtrack. And then, if I say push this, and then coming back, if alpha is, then we toggle the case, we backtrack again, we recurse again. And after done, then we're done with this. We go to the front. Oh, okay. I see how this one works. So basically, this is the DFS. This is exactly what DFS is. You go the left branch all the way down, which is just continually calling this, right? And once you're done, you're going back. Then you're going to change the last letter, toggle the last letter, and then you keep doing it again. And then going back to the previous level, you toggle the letter, and you do again. Yeah, it's a backtracking solution. I mean, backtracking does work with permutation, but I do remember in the past when I was first presented with different solutions for permutation, I mentally made it that I will not use backtracking, but use just regular recursion. That was funny. What was I? Oh, I was talking about using not backtracking, but the regular recursion. We just set aside one letter, we permute the remaining, and then we consider how the first letter is going to play with the rest. So that's my mental model for all permutation tasks. But apparently the backtracking also works. Yeah, backtracking also works. Yeah, you can leave a comment. This is good. I mean, this is the same as. I don't have. Essentially, DFS as described in the top loaded answer. I want to paste the link. Described in the top loaded answer. Post it. Yeah, this is DFS. Okay, so we know the backtracking. Backtracking. Yeah, it is backtracking. Change it and go again. Okay, change it when I switch. Okay, that's good. Oh, we've done this already. Product. Coders, friends. Even I. Don't be like this. This is fun. Come on. I just think about like making this all about interview. That's just a little bit. You devoid all the fun. Plus, you don't diss Elite 215. Come on. Oh, he. Oh, wow. He's still active. What is that? Yeah. Sometimes click around, no reason to follow. Exactly. Why you follow it? Okay, yeah, I don't care either. I don't care about tag. Either the issue. Yeah, the comment doesn't worth it. Yeah. Shoehorn Java into every other language. Oh yeah, I mean this is a sword in my eye, exactly. Time is the only constraint, or no one is care. How your variables are named. I mean, come on, man. You're taking away all the fun. Can I reply to this? Come on, people. Don't take away all the fun. Don't take away all the fun of doing LeetCode. Interview or not, that should be a side effect of practicing how do you select practicing? Is it right? A practicing LeetCode problem. Passing interviews. Should be a side effect. Don't you feel all the joy? All the joy, all the oohs and ahs when reading brilliant solutions from people like, I'm gonna add him. I want him. I have done my fair share of interviews. And honestly, with whiteboard, I've never done whiteboard before. Now, and honestly, with most interviews I have gone through, didn't even involve compiling or running the code. Compiling or running your solution. You just explain it and go through a few test cases. You just explain your solution and go through a few test cases. I have even passed interviews where my solution is not correct, but it solves the test case. So the test is provided. It solves the provided test case. Don't take all the fun from doing LeetCode. I've gone through, didn't even involve compiling running the code. Orally, and go through a few test cases. Not correct, but it solved, but it passed the provided test case. It passed the provided test case. Yeah, don't take away all the fun. It's the fun, right? Most interviews I've gone through didn't even involve compiling or running your solution. You just explain your solution orally. Did you even spell orally correctly? How do you spell orally? Yeah, I think I spelled correctly. But it's actually off the topic. I mean, the topic is to use. No, my point is just let me. Yeah, I don't think this is necessary. It's like yeah, I think this information is not necessary. Yeah, let me update it. This is not necessary. This is good enough. Okay, let's go back and just take a look at what you say, like oohs and ahs. What's the oohs and ahs? Okay, so What is this? Hold a sec. You can call lower on this? Oh my goodness, you can. Huh. Alright. So we have set, and then map, iter tools, product. Right? Product is, oh dear Lord, product. Let's go to tutorial. I think I know what this means. Let's go to see product. Product, a Cartesian product, equivalent to nested for loops. Cartesian product. So what it does is Cartesian product, right? So we do Cartesian product of all pairs, and we do Cartesian product. And after we do Cartesian product, what it returns, it should be, oh man, what does it return? So product, what does product return? It yield tuple product. So it yields each product, right? So basically it yields a lowercase and lowercase, like everything, right? Everything combined together as an iterable, whatever that iterable is, and then we just map it with a join. Oh my goodness, this is good. Oh wow. Oh wow. Very well done. Very well done. Wow. Yep. Cartesian product. Wait, is this another way to generate? No, it's not. It's possible. It works because we don't really have to move the letters around. That's the only reason why it worked. Man, like reading through all these solutions, my solution looks pretty bad. It's long, it's terrible, oh my goodness. This is good. Yeah, this is good. Whatever the tag is, I never read a tag. I don't even know it exists a tag. Okay, this is DFS. Yeah, this is DFS and the so-called backtracking. Yeah, it's backtracking. There's a one-liner. Product set. Yeah. I think product is. Yep. This is good. What do you mean by honest backtracking? Yeah, what do you mean by honest backtracking? Oh. Huh. Alright, we run through everything. So, yeah, and you gotta kind of know like my take on solving LeetCode problem. I mean, this is a hobby, right? This is a hobby of mine. I really like it. It kind of like a little bit brain exercise every day. I don't really worry too much about interviews and stuff. I mean, what I feel like is if you do LeetCode just like to prepare for interviews, it works for someone, but I think it takes all the joy away. It takes all the moment that you see all those good solutions, and you're like, oh, okay, and then you kind of just, improve yourself, right? I mean, at the end of the day, interview is not the end goal, right? The end goal is to make yourself a better programmer. I mean, there are many aspects of being a better programmer. These brain teasers is a part of it, getting you to check the part of the brain that you don't check usually, and this helps you improve yourself, right? And then interview will come as a side effect, right? So instead of, okay, I want to memorize how this problem is solved. So instead of thinking about that, it just, internalize it by just doing it often and often and often. I do, I do memorize solutions, right? Like I said, permutation, I don't like it, so I have to find a solution that I'm comfortable with and memorize it and solve problem with it. But I feel like this is quite different from, you see a solution you don't understand, or you see a solution that's really smart, and you just start to be defensive, like, oh, I don't think that one really works in interview. Nobody cares about interview. I mean, if you're at the level, interview will come. Interview will you will solve those problems, and people will notice, right? As you walk through your solutions, as you talk, it helps. All right. Anyway, that is for today. It's a good question. I really like it, and we have found a couple of different solutions for. Actually, I want to write the other one as well, but I'm not gonna do it right now. You know what? Let's do it. Yeah, we are at 1 hour 6 minutes. We probably can write it in like 5 minutes, probably even less. Oh, I need to reference. Let's write it first. So what we know is we're gonna use something called product. Yes. So I want to write a one-liner. So I'm gonna say return something for P in product. So what's going to be the product? It's going to be, why do we need a set? We don't even need a set. Oh, we do need a set. Yes, we do need a set, because if it's a number, yeah, it have to be a set. So it's in a set for letter in X. So the set is going to be letter dot upper and letter dot lower. And after we're done, we need to put this in a list and then deconstruct it so the product can work on it. And after the product works on it, we're gonna go P, right? So it's actually not gonna go P. How does map? I think map works on product itself. So the product is, yeah, I think map works. So we're gonna do map, right? And then the function we can use is called .join. Yeah, I think that's solution 4. What the hell? Set expected most. Oh, so it has to be this and this. Yep. It does pass. Now I just want to reference. Which one do you want to reference? Well, I want to reference Lee on this backtracking. Let's reference both, because Lee is the first one who I see. Where is Lee? Anyway, so we're going to reference him for sure. We're going to reference him, sure, use product. Very smart solution. Note that a numeric letters upper and a lower is the numeric itself. Okay, so we're gonna reference this and Lee. I see anybody respond to you? I don't think so. Okay. Alright, so that is it. Alright, that's it. That's it for today. I'll see you guys tomorrow for tomorrow's challenge. Yeah, we'll just keep working on this. You'll find the joy in it. Alright, bye. Adios.